here we go. Our next lesson is Appendix 6, which deals with rational exponents and radicals. So here, let's look at how the rational exponents will work. I don't think there's a good explanation there on this first part. So let's look at rational exponents and radicals. So if we look at rational exponents, basically what we're talking about is a fraction exponent, correct? So if I have something like 8 to the 2/3 power, well, this bottom, the denominator, will be the root of this number, and the top, the numerator, will be the exponent. Okay? Or as we call a radical. Okay? So we can look at this, or we can rewrite this as the cube root of 8. And we can put the squared in here, or we can put the squared in here. So let's write it both ways. The cube root of 8 squared. Okay, they are both going to equal the same thing. In my calculator, if I did 8 squared, which of course is 64, the cube root of 64 is 2. But if we don't have a calculator, if there's a no calculator section, then we might need to do the cube root of 8, which is 2. And of course, 2 squared then is 4. Oh, I apologize. And the cube root of 64 is 4. Okay. So, two different ways we could write that. It's a whole lot easier to get the cube root of 8 and then square it than it is to get the cube root of 64. So let's look at rewriting some of these or evaluating some of these. Most of these are pretty straightforward and simple. And a lot of these you could put in a calculator to get the gist of where they are. But we need to know some little ins and outs of these. So 4 to the 1/2 power, well, the 1 is the exponent, the 2 is the square root, so basically it's the same thing as the square root of 4. If I have negative 4 to the 1/2 power, we need to know if there is no parentheses there, okay, and there is not, then that 1/2 is only applying to the 4. So that's basically the same thing as saying negative 1 times 4 to the 1/2 power. Okay? Or you could think of it as negative, and then it's 4 to the 1/2 power. That's the same thing. So 4 to the 1/2 power is 2, and that would be a negative applied to it, so it would be the same thing as negative 2. Okay? However, one thing we need to understand here also is when we take the square root of 4, and we'll go over this, I think there's a little caution in this, and I'll point it out here in a minute. It is not the plus or minus 2. It is only plus 2, positive 2. Okay? Why is that? Well, because it's not an equation. If I had x squared equals 4, and then I square root both sides, well, now I have an equation, or I would equal. Then it would be x equals plus or minus 2. So when we don't have an equal, and we're just taking the square root of 4, it's just 2. There is no plus or minus without an equal sign. And then another thing we need to understand is if I have the square root of negative 4, that is an imaginary number. It does not exist. Okay? It exists on the imaginary plane, and we could write that as 2i, but we are not working on that in this section, so don't worry about the imaginary numbers here in this section. So let's look at some other examples. If I have negative 8 with parentheses to the 1/3, well, negative 8 with parentheses to the 1/3 is the same thing as the cube root of 8, of negative 8, I'm sorry. So when there is an odd number as the cube, and I have a negative number, well, that's not necessarily going to be an imaginary number. For example, when we had the square root of negative 4, well, square root means, let's just look at square roots real quick. What is the square root of 4, and why is that? Because 2 times 2 equals 4. And so the square root is the opposite of 2 squared. Okay, so 2 times 2 equals 4. So the square root of 4 is 2. They go back and forth. Okay. However, the negative 4, I don't have something that I can multiply times itself. In other words, 2 squared cannot equal a negative, because when I'm squaring it, or it's an even number, it's always going to come out positive. So if that is an even number on the root, I cannot have a negative here without it being an imaginary number. Okay. However, a cube root, the cube root of 8 is 2. Why is that? Because 2 cubed equals 8. 2 times 2 times 2. Well, now that this is odd, the cube root of negative 8 could be negative 2 times negative 2 times negative 2, and that can come out as a negative. So the cube root of negative 8 is a negative 2, and so it does not deal with imaginary. If it's fifth, 7, 9, so forth, as an odd number, it can have a negative underneath there. So just understand here, 8, negative 8 with the parentheses to the 1/3 power is negative 2. Okay. And then, of course, negative 8 to the 1/3 is going to be the same thing, because it is the cube root of 8, which is 2, but then the negative gets applied to it, which is also negative 2. And here was my warning a minute ago with this little caution saying that we don't do the plus or minus here unless it's an equal sign. Okay. It's only positive 2 because it's not an equation. Okay. Let's see if there's any more. Oh, when we get the negative. Okay. So let's look at our next page and we'll look at a couple of examples here when I have negative exponents along with my rational. Okay. Y to the negative 2/3. Well, that's just going to be written as 1 over y to the 2/3, or in other words, the cube root of y squared. Okay. Could it be the cube root of y to the negative 2? It could, or it could be the cube root of 1 over y squared, but you could keep it just like this right here. Okay. And how can we rewrite it like that? How can this be the same thing if you're curious? Because we could have, the reason we could have the root of 1 over the cube root, I'm sorry, why did I do the cube root there? Y squared, and this being the cube, because with this 1 up here, this would be the same thing as the cube root of 1 over the cube root of y squared. Well, the cube root of 1 is just 1, so right there, same thing. So it can be rewritten like that. Okay. Here I have the square root, or the fifth root of 6, 6 to the 1/5 power. The square root of x squared plus y squared, I can rewrite that as parentheses x squared plus y squared to the 1/2 power. Just understand where that root goes is going to be key in how you're going to represent these with your exponents. Okay. So working with rational exponents, if we have something like this here, and I'll just go over some different examples. Here I have a 4 on the outside. Well, I've got to distribute that to everything in there. So that would be the same thing as 2 to the 4th power times x to the negative 3/4 to the 4 power. Let's write that, okay, times y to the 1/4 to the 4 power, okay, times, oh, and that's it, okay. So 2 to the 4th power, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, so I have 16 here. Here I distribute this. This would be negative 3/4 times 4. Well, the 4's would cancel out, and I'm left with x to the negative 3. And then here, y to the 4th to the 1/4 power. Again, the 4's cancel out because I'm multiplying. So that would just be y. Now, does it say answer using positive exponents? It does. I have a negative exponent here. So I'm going to end up with 16y over x cubed. Here, same thing. Let's look at this next one real quick and we'll start wrapping this one up because we're going to have to be converting back and forth. So here I'm going to have distribute this to everything in there. That's going to be 8 to the 1/3 power times x to the 1/2 power, time to the 1/3 power over x to the 2/3 power to the 1/3 power. Well, x to the 1/3 power is just the cube root of 8, or 8 to the 1/3 would be 2. X to the 1/2 times 1/3. Well, I'm going to multiply 1/2 times 1/3, which would end up being x to the 1/6 power over x to the 2/3 times 1/3, and that's going to be x to the 2/6 power on the bottom here. Okay, we'll have an x over an x, so I want to bring this one up, and I'm going to multiply it with the negative 2/6. Oh, I'm sorry, this just becomes 1/3. But actually, I want to keep it as a 6 because that's going to keep things a lot simpler when I'm adding. So x times x have the same basis, so I'm going to add these. So I have 2 times, and I have x to the 1/6 plus negative 2/6. Add those together, and I'm left with 2x to the negative 1/6 power. Can't have the negative 1/6, so I'm going to bring that to the bottom. So my final answer would be 2 over x to the 1/6, or in other words, 2 over the 6th root of x. Okay, because it says use exponent forms, and if rational exponents appear in final answer, convert to radical form. So we needed to convert it to a radical, or in other words, a root. And so it's 2 over the 6th root of x. Hopefully that simplifies those for you on how we can answer these converting this way. And then converting back the other way, I think should be pretty straightforward. If we have roots and we need to convert it back to rational exponents, then here 2 root x minus 3 cube root x squared, well, that'd be 2x to the 1/2 minus 3x to the 2/3 over 2 to the 1/3, 2x to the 1/3. Now, when I have a plus or a minus in my numerator, I can split my denominator. For example, 3, let's just say, I don't know, let's do 8 over 3. That could be written as, no, that's not a good example. I need to use some exponents in that example. For example, x plus 4 over, let's just say 4. I can split that. That'd be the same thing as x over 4 plus 4 over 4. Right? When we have that, we can, as long as we have a common denominator, we can just put what's in the numerators on top in our common denominator. Well, we could go the opposite way as well. So here I'm going to split this 2x to the third. So I have 2x to the 1/2 over 2x to the 1/3 minus 3x to the 2/3 over 2x to the 1/3. Simplify this. 2 over 2 is 1. 1/2 x to the 1/2 over x to the 1/3. I bring this up and I add them together. That would be x to the 1/2 plus negative 1/3. Well, now that I'm adding, I need to make both of these with a denominator of 6. 1/2 of the denominator of 6 is 3/6. 1/2 with that would be 2/6, and it's negative. Add those together, I have 1/6 positive. So that leaves me with an x to the 1/6. Here I have 3 over 2. And it's saying put it as a decimal, because I don't want this as a fraction, so I'm just creating it as a number. 3 over 2 would be 1.5. And then x to the 2/3, x to the 1/3. I bring it up, subtract it, it's going to leave me with x to the 1/3. And that should be it for our radicals. Let me go over a couple of properties of our radicals, which I think we did a little bit earlier. And that is, if I have a two radicals multiplied, two numbers multiplied underneath the radical, I can split that radical. Okay. Or if I have a fraction underneath my radical, I can split that radical into the fraction on the top and the bottom.